Hey guys, welcome! In this video, I am going to discuss about centroids of composite bodies. But before anything else, I would like to introduce myself. I am John Jake Narral, BSc, major in Structural Engineering. Let's define first what does a composite body means. When we say a composite body, it consists of a series of connected simpler shaped bodies which may be rectangular, triangular, semicircular, etc. Such, a body can often be sectioned or say divided into its composite parts, and provided the weight and location of the center of gravity of each of these parts are known, we can then eliminate the need of integration to determine the center of gravity for the entire body. It means that if the body can be divided into its composite parts, weight and center of gravity of each parts are provided, then the center of gravity can be solved without the use of integration, which can be a good thing for those having hard time in integral. Please take note guys that this statement is also applicable for finding the centroids of a given area, volume, and mass. Nakadepende po yan kung ano po ang nire-require sa isang problem. In finding the centroids of a composite body, here are the formula that we're gonna use. Bar x is equal to the summation of the quantity of x times w divided by the summation of w. Bar y is equal to the summation of the quantity of y times w divided by the summation of w. Bar z is equal to the summation of the quantity of z times w divided by the summation of w. Where bar x, bar y, and bar z are the coordinates of the center of gravity of the composite body. X, y, and z are the coordinates of the center of gravity of each composite part of the body. And the summation of m is the sum of the weights of all the composite parts of the body, or simply the total weight of the body. Since pareho lang naman po ang idea, finding the centroids of a composite area, volume, and mass will be found po using relations analogous to the formula of weight. Substitute lang po sa W sa formula ang A, V, at M. Where A is for the area, V for volume, and M for mass. But take note po, here in area, exclude na po natin yung bar Z since the body is only bounded with X and Y plane. To have a greater understanding, let's have an example. For the first problem, locate the centroid of the shaded area. The first thing we're gonna do is to divide the body into a finite number of composite parts that have a simpler shapes. So in this problem po, we can divide this body into 3 parts. 1 for rectangle, 2 for triangle, and 3 for a circle. Then, we will do the table method. At the left side, it indicates the number of composite parts. And at the top of the table, it indicates the coordinates of the center of gravity, area, and the products of the coordinates and area of each composite parts. We will then identify the centroid of each segments or parts. For shape number 1, the x-bar of a rectangle is half of 7, which is 3.5. And its y is half of 6, which is 3. The area is 7 times 6, which is 42. At para po madali nating masolve ang XA at YA, isi-shift stack to A po natin. So, alpha A times X na 3.5 is 147. At A times Y na 3 is 126. Next is for the second shape na triangle. Remember that the x-bar for a right triangle is 1/3 of the base, and the same manner goes to its y. So 1/3 of 6 is 2, plus the distance na 7 is equal to 9. And for its y, 1/3 of 6 is 2. The area of a triangle is 1/2 times base times height. So substitute the values. 1/2 times base na 6 times height na 6 is equal to 18. At isi-shift stack to A rin po natin to para mas madali nating mahanap ang XA at YA. So alpha A times X na 9 equals 162, and alpha A times Y na 2 equals 36. The last shape is the circle. Remember that the bar X of a circle is at the center of the circle. So in this problem, the bar X of a circle is at 7. And for its Y, it has a distance of 3 meters. The area of a circle is equal to pi r squared. Since the diameter of our circle is 2, then the radius will be 1. Basically, 1 squared is equal to 1, then our area will be equal to pi. But take note that if a composite body has a hole, then consider the hole as an additional body part having negative unit. Then our area for a circle will be negative pi. XA is equal to negative 7 pi or negative 21.99. And for YA, it is equal to negative 3 pi or negative 9.42. Now, let's find the total sum of A's, XA's, and YA's. The summation of A is equal to 56.86. The summation of XA is equal to 287.01. And the summation of YA is equal to 152.58. Now, according to the formula, the bar X of a composite body is equal to the sums of XA's divided by the summation of A. Likewise, to the bar Y, it is equal to the summation of YA divided by the summation of A. Then, substitute the given values. In XA, we have 287.01 divided by 56.86, which is equal to 5.04766 or 5.05 meters. And for bar Y, 152.58 divided by 56.86, which is equal to 2.6834 or 2.68 meters. And for our final answer, 5.05 meters for bar X and 2.68 meters for bar Y. Let's have another example. For the angular section shown in the figure, determine the centroid from the X and Y axis. We will do the same process just like in the first problem. So, I will take this vertical rectangle as my first part or first segment, and I will take this at the bottom rectangle as my second segment. Since it has a thickness of 10 mm, the bar X of the first segment will be 5. And for its y, 125 divided by 2 is 62.5. The area of the first segment will be 125 times 10, which is equal to 1,250. So, shift stack to A, and alpha A times x na 5, alpha A times x na 5, it is equal to 6,250. And for its YA, alpha A times y na 62.5, it is equal to 78,125. For the second segment, let's subtract the thickness of the first segment. Then, it will have a total length of 65 mm. So, for the bar X of the second segment, 65 mm divided by 2 is equal to 32.5, plus the thickness of the first segment, we will have a total of 42.5. And for its bar Y, since it has a thickness of 10 mm, then y is equal to 5. The area of the second segment is 65 times 10, which is equal to 650. So, shift stack to A para mas mabilis. And alpha A times x na 42.5, it is equal to 27,625. And for its YA, alpha A times 5 is equal to 3,250. Then, let's find the total sum of A, XA, and YA. So for A, we have 1,900. For XA, 33,875. And for YA, 81,375. Now, let's find the centroid of this section using the same formula. So for bar X, we will have 33,875 divided by 1,900. We will have 17.8289, or say 17.8 mm. And for bar Y, we have 81,375 divided by 1,900. It is equal to 42.8289, or say 42.8 mm. And that is our final answer.